Hello everyone and welcome back to PostNetwork Academy. I am Bindeshwar and today we are going to explore an important topic in probability, statistics, artificial intelligence and data science, that is continuous random variables and probability density function. Before we dive in, let's take a moment to understand why this topic is crucial. Continuous random variables play a fundamental role in various real-life applications, from weather forecasting to stock market predictions and even in AI models. So, a random variable is continuous if it can take any real value within given range. So, instead of probability mass function, for a discrete random variable, we were telling probability mass function. We will use probability density function for a continuous random variable and we will denote it by fx. So for discrete random variable, we use probability mass function, and for a continuous random variable, we use probability density function. So these two terminologies we will use, and the probability that x lies in an interval AB, that is given by P, that x lies between A and B, integration from A to B fx dx. Now the total probability must sum to 1, so from minus infinity to infinity, if you integrate probability density function, it must be 1. And using these two properties, we'll see two questions, we'll solve it, and you will understand that what is basically probability density function. So here a question given that probability density function is given, and also range. Here you have to consider range. Don't forget to see that x lies between 0 and 1. So see that the if you integrate probability density function, so it must be 1. So this way we can calculate the value of a. So here if we compute the integral, so we will get a is constant, so we can take it out, and thereafter integration and just find the limit. So from 0 to 1, that will come a into 1 upon 4. That means a upon 4 is equal to 1, because you are summing, or you can say that integrating from 0 to 1, and here is our limit. So the value of a will be 4. Now so if we solve for a, so that would be 4. Let us see another example to find probability that x lies between 0.2 to 0.5, while here density function is given. So what we will do, P probability of x which lies between 0.2 to 0.5, that would be, you will integrate density function from 0.2 to 0.5, and finally what will we get here? X is 4 is a constant, so we can take it out, and thereafter after integrating x cube, we will get x raised 4 upon 4. That means let us remember, if you have a function fx xn. So if you integrate with respect to x, so what we get, fx dx, that would be equal to xn plus 1 upon n plus 1. That's why here we are getting, if it is x to the power 3, so after integration you will get x3 plus 1 upon 3 plus 1, and that would be equal to x4, x raised 4 upon 4. So here, and we will put limits. Upper limit is 0.5, lower limit is 0.2. So here you will get 0.0609. So this was very simple examples. Hope you understood. More complex and important examples I will bring for you. For more resources like simulation, articles or posts and videos or quizzes, you can visit www.postnetwork.co. You can also visit YouTube channel for videos and playlist. You can also connect to Facebook page, and you can also follow PostNetwork Academy LinkedIn page. So hope you understood. Thanks for watching the video.